Hello. Hello, everyone. I am Caitlin McAtura, and this is Hugh Herr. Hugh Herr is a double amputee. He's also a professor at MIT, and he does a lot of research with biomechanics and augmented systems for human empowerment. This is actually his TED Talk that he gave. Now, I've been interested in prosthetics for a very long time, since I was younger, and it's actually what got me interested in engineering, and it's the reason why I know about people like Hugh Herr and a lot of the research that's going on even here at Northwestern in prosthetics as to how they can transform the lives of some amputees. So I knew I wanted to do my thesis project around prosthetics. And this was kind of the mindset that I went into it with. I knew about guys like this. I knew about a lot of new tech going on. Things like there was a Dancing with the Stars contestant who is a double amputee, and she's clearly getting around pretty well. She can come in second with Dancing with the Stars. So this is the mindset that I entered into this project with. But what I found when I was actually going into clinics was something that looked a little different. It looked a little bit more like this. And this looked kind of like the back of an artist's workshop to me, much messier, much less technical than I was expecting. And what I found very quickly is that prosthetists really consider themselves to be craftsmen. So they're working on an individual basis to try to improve the lives of each patient that comes in. And they're literally crafting and designing a leg for each patient. And this is where they do a lot of their work, in environments like this. They also have tool benches, which probably resemble some of your tool benches in your garage, also very messy, non-technical. So I realized that prosthetists don't really need complex data-driven systems. They need tools, and they need tools that can adapt to different patients as they go throughout the day. So with this kind of understanding of the environment that I was working in, and then needed to narrow down on where I thought I could help. So if we go back to this prosthetic, there's kind of two main general categories of what goes into a prosthetic leg. First, we have the components, which includes ankles, knees, feet, and that's where a lot of the fancy tech stuff is happening. And then we have the socket. And this is the actual interface between all this machine stuff and the human. And the socket is critically important to a prosthetic for several reasons. First, if you have an ill-fitting socket, it can actually cause sores and blisters. It can cause hip problems and back problems. And ultimately, it can cause the patient to not even wear their prosthetic. So I actually met a patient who had been an amputee most of her life, but she never wore her prosthetic for several years. She was getting around on crutches because she just couldn't get the fit right to where it was comfortable enough. So I wanted to dive deeper into the socket and how it's made and learn more about this process. So I'm going to take you through the socket making process. And this whole process is just kind of a slice of the whole getting a prosthetic routine. So if we start from the beginning, the patient would come in and they would get a cast done of their leg. So this is to capture the anatomy and give the prosthetist somewhere to start. Next, they use that cast to create a positive mold. So this is kind of a replica of the patient's leg at this point. But as you can see, it's pretty rough and it needs to be shaped down. So they shape it down to something like this. And not only are they getting rid of kind of the roughness on the surface, they're also shaping it to try to get the best fit. And in this case, for below the knee amputees, this means putting pressure in the right places and not pressure in other areas. So if you think about below your knee, you have a lot of bones here. You don't want a ton of pressure there. But on your calf, where it's more squishy, you can apply more pressure there. So that's what they're hoping to do. And the amount of adjustments that they make here is based purely on experience and intuition of knowing kind of what would work for the patient. There's no real set way of figuring out how to do that. Next, they take that shape that they just made and they make a check socket, which is just a clear plastic thing. And this is not something that amputees would wear around because it's not safe, but this is mainly for fitting purposes. And that's the next step of the process. You get these check sockets, the patient comes in, tries them on, walks around a little bit, and they make adjustments to it. Once the adjustments are done, so these are all Sharpie marks from where the adjustments happened and where they needed to fix things, they take this check socket, and that's what they use to make the final socket that the amputee will actually wear for several years. So in this process, the really critical part is the fitting, because how well this goes determines how well their prosthetic fits that they're going to be using for years to come. So this is where I wanted to focus in on. So we're going to take a little look at what actually happens during a fitting. So here we have a patient walking back and forth. He's a double amputee. And what happens is the patient will go in, try on their legs, the prosthetist will quickly check, make sure it's safe basically, that it's contacting all parts, and then it's up to the patient to tell them where it's uncomfortable, where they don't feel like it's right, and they walk back and forth. And there's actually 2 prosthetists standing here looking at his gait as he goes back and forth trying to figure out what's wrong. And right now one of his feet is turning in as he keeps walking, so he was complaining that something felt too loose. So they think, okay, we try to tighten it. The prosthetist will take it back. He's like, okay, I think it might be here that it's too loose. He uses a heat gun to heat it up, and then he just uses a gloved hand to try to shape it and mold it in. They take it back to the patient, he tries it on, he actually couldn't get it on this next time, it was too tight, so they had to go back, fix it, and this process can take several hours. In addition, if they don't get it close enough, the patient has to come back in for another check socket fitting, and this whole process happens again. So this is exactly where I wanted to focus my time. And there's not only the problem of time, but there's these 4 main issues that I found. First, from the prosthetist perspective, the person making this, he was frustrated because he said the hardest part is that I can't feel what they feel. So sometimes he said they'd be describing some sort of pain or discomfort, but he'd be seeing something different. And he said it was really hard to kind of converge those 2 things and to create a socket that was a really good fit. Then from the patient side of things, this is Christina. She was a double amputee that I talked to a lot during this process. And she's been through this process several times. She described it simply as it's just a shot in the dark as to whether they can get it right or not. So there's a lot of doubt as to kind of what the prosthetist is doing in this process and if they're going to get a good fit in the end. Next, we have the issue that are more physical that result from amputation. So many patients have actually lost feeling. So if you're relying on the patient to tell you where there are areas of discomfort, but they can't feel all parts of their limb, there could be areas that could cause sores and blisters later on when they wear it for a long time that they simply can't tell you about because they can't feel it. And finally, you have this issue of referred pain, which Christina also experienced. So this can happen when you're feeling some discomfort on one side of your leg, but it's actually caused by something on the other side of your leg because the nerves can get crossed and you can have phantom pain from your residual limb. So for all these reasons, I wanted to create something that would improve this process both for the patient and for the prosthetist to make it a little more certain of what's going on. So initially I thought of some sort of visualization tool that would help with the communication and pinpointing problems in the socket. I explored a lot of different methods. Some are pictured here. I also looked at LCD displays, polymers that change color under pressure, load sensors, and I finally settled on this fabric, which is the black fabric you see in some of these early prototypes. And this is kind of the anatomy of how IMPRINT actually works. So the middle layer is a piezo-resistive fabric, and all this means is that when you press on this fabric, the resistance changes. So if I put 2 electrical contacts on each side and I press, I can tell what the pressure is. And then expanding that out, if I take it and put it in a grid, so I have contacts on each side, then I can tell how much the pressure is and where that pressure is located. And I ended up using conductive thread for the contacts because it needed to be flexible to fit into the socket as they're checking it out. So you take all these layers and you sandwich them together and you get IMPRINT. And I'm going to show you a working demo of kind of the working concept of this really does sense pressure and tell you where it is. This is me just pressing on a sensor, and this is my computer screen, and as the squares get lighter, that's higher pressure, telling me where I'm doing it. So this is kind of just the working model, but what I envision the actual IMPRINT working like is something like this. So if you noticed earlier in the fitting, the patient was wearing socks, which is very common. Most amputees wear socks, and so they have to wear them during the fitting. So you can take this same idea and embed it in a sock in a grid system, use this sock during the fitting. So he would put the sock on just like this, just like he would a normal other sock. Then he can put the check socket on and go about the fitting. Then the prosthetist and the patient can both see this kind of heat map, and it's in this funny shape because that's what a sock would look like unfolded flat. And they can see an area here. So in this case, in like the upper left corner, there's some high pressure, and he thinks, all right, let's try to fix that. He goes back, makes adjustments, and now he has something to compare it with to see how much they improved. So it looks like they knocked the pressure down some. Maybe he has to go back more depending on how uncomfortable the patient is. In addition to that, you can also look at pressure over time. So as the patient is walking through their gait cycle where there are specific areas. So the prosthetist can select an area of interest if he just wants to look at some, and then have the patient walk. So in this way, the patient and the prosthetist both have some reference of what they're doing and what they're aiming for. So I see 3 main benefits to this. First is it might not let the prosthetist feel what the patient feels, but they can at least see it, and they can get a better idea of what they're going for. It also brings some data into this process that is mainly a subjective process, right? So it doesn't interrupt the workflow of the prosthetist at all, but it gives him some idea, something to shoot for. And in addition, over time, he can also learn that what pressures to avoid either on the high end of the scale or the low end of the scale. And finally, it empowers both the prosthetist and the patient to communicate better and have some point of reference between the uneducated patient. He doesn't know, that it's his MCL connecting to his shin and midway through the gait cycle that's causing the problem. He just knows that it hurts. So they can help look at this map and see what's going on. So if I had a thesis 2.0, it would now be fixing the heat gun side of problems, and the adjustments could be more precise. But in the meantime, this is IMPRINT, and I think it's one step closer to a better fit. Thank you.